My name is Jiang Li Cheng, and today I'd like to talk about my project, Automatic Player Occurrence Identification in Sports Videos using audio-based recognition and visual face matching. So what's the problem I'd like to solve? Sports broadcasters still depend on human scrubbing through hours of footage just to find where a player shows up, and it's slow, error-prone, and wastes lots of production time. So how does this project impact and hope to solve the issue? So my project hopes with that to speed up player search by reducing manual editing work and improve accuracy and identifying player moments. This can lay a foundation for future work as well. So here's the system overview. So we feed several videos as well as a player name that we like to search. Then we look into our cache to see if we have run this previous task before. If this cache does exist, then we just get the previous results. If no, then we just run the audio-based recognition and or the visual-based recognition. Once done, we save the results and get the results which is in the form of several segmented clips. Then we feed those segmented clips into highlight recognition module, which then determine which one is a normal clip and which one is a highlight. And here's the audio-based recognition. So we feed in a video and we feed it into a speech-to-text module, which then returns transcripts. Then we feed in the player name that we'd like to search. Then we run one of three methods. Sorry, one is the name entity recognition and string matching. Another is built on the first method, but we add LLM correcting. And finally, the third method is just name entity recognition as well as LLM-based extraction, and it'll return segmented clips. And here's an experiment for the audio-based recognition. We evaluated our three methods, and we performed this test on a short highlight reel based on a Hawks versus Pacers game. And the key takeaway is that A is the fastest and most stable with 0 false positives. B gets perfect recall, but rather poor precision and a lot of latency from local LLM correcting. C is most balanced, but still very slow since we're using local LLMs. The second experiment is we tested on a full game and we tested each player, 4 specific players from the game. And we tested Spencer Dinwiddie, Kyrie Irving, Klay Thompson, Derek Lively. And here are the key takeaways that A remains the fastest by orders of magnitude, and B produces highest recall, but still low precision and latency, as well as C also has latency, but higher precision, mostly because of the local LLMs. Now is this visual-based recognition. We have a video, we extract the faces of the players, and we run a face verification check with the faces in our player face data set. Then we check if it's true or false based on a certain threshold or another verification method, and we return the clips. And here's an experiment we ran. We compare crop faces against all players, and then we set a threshold of 0.68. And we observed here that there's a massive potential frontal and profile gap here with our ArcFace, for example, 66% and 19%. This threshold is too strict for messy broadcast footage, and older models fail completely. And here, ArcFace is the most reliable. And for a second experiment, we abandoned the threshold and we used nearest neighbors. And the accuracy improves sharply across all models, and ArcFace improves a lot, but frontal still dominates and profile still bottlenecks. Here's the highlight recognition module. It's a very simple fine-tuned transformer that we use to classify highlights and non-highlights. The data set includes 120 highlights, 240 non-highlights. And the performance, we compared it with pre-trained models on Hugging Face and 3 models that we fine-tuned on our data set. And we see that the fine-tuned transformers perform very well and exceed the pre-trained models. And here's a quick demo from our UI. We can drag and drop the videos, but for time's sake, I'll just use the already pre-processed videos. Here in what we see, we can select the players you want to search. And over here, we can see the audio hits, the visual hits, and the overlaps. We can also search for another player like Jaden McDaniels here, and yeah, same result. Also we can download the results and save and open here. We can see the corresponding clips to the player and the video. As for the conclusion, we developed a player detection system that integrates audio-visual recognition with highlight detection, and we achieve reliable performance on our test video showing that there is potential for multimodal fusion in sports analytics. However, processing time for LLM-based techniques are heavily impacted by our inferior local hardware, learning LLM components, as well as the small amount of data in our dataset, causing a possible overfitting in our highlight detection. As for future direction, we hope to expand and diversify the dataset. We hope to refine algorithms for higher robustness and their accuracy, and we hope to move components to a proper API or compute service to eliminate local hardware bottlenecks. Thank you for listening.